Welcome to doassignment-ca. Here is the problem. A roller coaster car is essentially at rest at the crest of hill A. Determine the required height h so that the car reaches a speed of 100 kilometers per hour at the bottom of hill B. Also determine the minimum radius of curvature ρ for the track at B so that passengers do not experience a normal force greater than 4 times mg. Neglect the size of the car and passengers. Now, let us work through the solution step by step. First, convert the speed at point B from 100 kilometers per hour to meters per second. Multiplying by 1,000 over 3,600 gives approximately 27.78 meters per second. Taking point B as the elevation datum, the car starts at rest at A, so its initial kinetic energy is 0, only gravity does work. Applying conservation of mechanical energy, the potential energy at A equals the kinetic energy at B, giving mgh equals 1/2 mvb squared. Canceling mass and solving for h gives vb squared divided by 2g. Substituting 27.78 meters per second and g equal to 9.81 meters per second squared yields a required height of approximately 39.3 meters. At the bottom of the curve, the center of curvature is above the car. The net upward force provides centripetal acceleration. Newton's second law in the normal direction gives normal force NB minus weight mg equals m times vb squared over ρ. Setting the normal force equal to its maximum allowable value of 4 meter g and substituting the weight term 4 meter g minus mg gives 3 mg on the left side. The mass cancels from both sides, leaving 3g equals vb squared over ρ. Rearranging gives ρ equals vb squared divided by 3g. Substituting 27.78 meters per second and g equal to 9.81 meters per second squared yields a minimum radius of curvature of approximately 26.2 meters. In summary, the required height h is approximately 39.3 meters, and the minimum radius of curvature at B is approximately 26.2 meters. Back substitution confirms that the speed at B is 27.78 meters per second, and the normal force equals exactly 4 meter g, satisfying both conditions. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.